Imagine trying to count every person in a huge crowd, or tasting every cookie in a bakery, or measuring every fish in the sea. It's impossible to check everything, yet amazingly, we can still understand big groups by studying just a small part of them. That ability is called inferential statistics. Inferential statistics helps us learn about an entire population without studying everyone. Instead, we take a sample, a small, manageable part of the group, and use it to make conclusions about the whole. It's the same logic as tasting a spoonful of soup to know if the entire pot tastes good. A population is the whole group you care about. A sample is the part you actually observe. But choosing the right sample is important. If you scoop only the oily part of the soup, you won't know what the whole pot is really like. So why not measure everyone? Because it takes too much time, too much effort, and often too much money. Estimation helps us guess unknown population values using sample results. For example, if 12 out of 20 people prefer singing than dancing, we estimate around 60% of the entire group might prefer it too. We don't know the exact number, but we have a solid estimate. Hypothesis testing checks whether an observed difference is real or just a result of chance. If students taught with a new method consistently score higher than those using the old method, and the difference is too big to blame on luck, we conclude the new method is likely better. Anytime you take a sample, randomness plays a role. Maybe your sample got unusually tall people. Maybe the first 10 cookies you tasted were sweeter than the rest. Inferential statistics tries to measure how much of a result is due to actual patterns and how much is just a random chance. Instead of giving one exact answer, we often give a range. For example, the average price of milk is probably between 60 and 70. That range is a confidence interval, a safe zone where the true value is likely to fall. A p-value tells us how surprising a result is. If the original assumption were true, low p-values means this result would be very weird if nothing different were happening. High p-value means this result could easily happen by chance. It's basically a weirdness score. Inferential statistics power surveys, medical studies, product testing, market research, and scientific discoveries. Like tasting a spoonful of soup, inferential statistics helps us make big conclusions from small samples. It's how we discover big truths using small data.